Hi everyone, my name is Bruno Fruchard. I'm very happy to be here presenting side-crossing menus enabling large gesture sets on small surfaces on behalf of my co-authors Eric Le Collinet and Olivier Chaput. In this work, we were interested in small wearable surfaces, like the smartwatch you can see here on the picture. These kind of devices provide two main advantages. First, they enable the hands of the users to be free and interact with the physical world. But most importantly, we carry them with us all the time, meaning that when we are interacting with a computer or when we are interacting in a virtual reality with a virtual reality headset, we have them with us. So that made us wonder, could we use a single controller to control various environments like this? For instance, could we use a smartwatch to control a mixed reality headset? Using the same smartwatch to control IoT devices at home in a smart home context? Or again, the same smartwatch to control large displays at work. So the strategy we're adopting here would be one smartwatch to rule them all. So the challenging part in this is that wearable devices like that have very small surfaces and they constrain the interaction possible. So what we propose is to use side-crossing menus, a new just right interaction technique that relies on position-dependent and path-flexible gestures. It provides a novice and expert modes, supports eyes-free interactions, and provides broad and shallow menus. I'm gonna go back on that in more details later. So first, let me dive into the interaction design of SCM. So SCM relies on a grid layout, as you can see here, and an SCM gesture consists of three main components. A starting cell, an ending cell, which makes it position dependent, and we consider the side cross of the ending cell. So considering the side cross actually expands the number of gestures we can have on a very small surface, like a smartwatch as you saw. So now many different gestures can start from the same starting cell, which in a sense creates a menu. So SCM relies on menu and provides a novice mode to help users visualize the gestures and learn them. As you can see here, we have 8 menus close to the bezels of the smartwatch. The user can press on a menu to open it, then see all the different commands she can select, and then perform a gesture to select a command, here crossing the right side of the ending cell. Now what's interesting with SCM is that it's path flexible, meaning that the user can take several paths to perform exactly the same gesture, as you can see here. Those two paths actually trigger the same gesture. What's interesting in this is that users can use different strategies, or they can go with the gestures they prefer. Another thing is that they can correct the gesture if they know that the trajectory was wrong, they can correct it. Now, how do we support eyes-free interactions with SCM? For that, we use two very simple aids. First, we use active vibrotactile aids on the screen of the display. That is, when the user enters a cell, there is a short vibration, so that can help when drawing a gesture. The second thing is passive tangible aids on the bezels. So these aids help to locate the starting cell, which in turn helps to perform bezel gestures. The last important thing about the SCM design is that it relies on broad and shallow menus versus deep and narrow hierarchies that more conventional techniques use. Let me explain that. SCM, as we saw, relies on 8 menus that only have one level hierarchy, and each menu can have 21 to 22 items, which at the end is a total of 172 gestures. Now if we look on the right here as the multi-stroke marking menus technique, it also uses 8 menus at the beginning, but at each level it can only have 8 items to be efficient. So at the end, to have the same number of gestures or approximately the same number of gestures in total as SCM, we will need 3 different levels. We actually compared those two techniques in the experiment later. The first thing we were interested in is SCM usable and what's the usability of SCM? So for that, we performed an experiment with 12 right-handed participants and 2 questions in mind. How fast can users master SCM and how efficient are SCM gestures? In this context, we asked the participants to perform the gestures eyes-free, that is, to use the expert mode of the gestures. The task was to perform SCM gestures as accurately as possible. The only visual stimulus they had was the starting cell, the ending cell, and the side to cross. For all the rest, they did not see the watch and could not look at the watch. What did we learn from that? that first, the participants could perform 95% of the gestures accurately after 20 minutes of practice, which shows that SCM can be mastered quite quickly by novice users. The second thing is that the gestures in the last block lasted around 3.55 seconds, which is quite long, but you have to consider that these were novice users using eyes-free gestures, which is quite challenging. And finally, we observed that the participants took various paths for the same gestures. Here you can see that for a single gesture, the participants used different paths and different strategies, even though they were not instructed to do so. So that's quite interesting. It shows that they can take advantage of this feature of SCM. Now, the second aspect we were interested in was to know more about the learnability of SCM. For this, we performed a second experiment with 12 new participants, and we had two other questions in mind. First, are easy RSM gestures to learn? And second, do shallow menus facilitate learning over deep menus? So as I showed you, we have here two different strategies because we compared to the marking menus. What was the task? The task was to learn gestures with the novice mode, so seeing them and then recalling them in the expert mode, so not seeing these gestures anymore. What did we learn? We observed no significant differences between the hierarchies in terms of recall rates and no significant differences between the hierarchies in terms of trial completion times. The times were again quite long, but this was in the context of eyes-free interactions. So what we conclude from that is that this experiment yielded comparable performances for the two hierarchies, meaning that SM is actually an interesting alternative to conventional techniques using deep and narrow hierarchies. Thank you for your attention, and I'm happy to take any questions.